Hi, everyone. Welcome to this edition of podcast on AI monetization by ProjectPro, where we speak with industry leaders on business outcomes related to AI. Today, we have with us Eric Siegel. Eric is the founder and CEO of GooderAI, a company that is focused on measuring business outcomes of AI. He has been a passionate about ML for almost 3 decades right now. When he started off as an assistant professor of computer science at Columbia, where he was also awarded the Distinguished Faculty Award. Eric is also the founder of the popular conference series Machine Learning Week, previously known as the Predictive Analytics World, that's been running since 2009. And Eric is also the author of the best-selling book, Predictive Analytics, The Power to Predict Who Will Click, Buy, Lie, or Die, which has been used as a textbook in hundreds of universities. And he's also addressed the issue of non-deployment of predictive analytics projects in his more recent book, The AI Playbook. And Eric also happens to be the executive editor of the Machine Learning Times. Eric, thank you so much for taking time to be here with us.
Thanks, Benny. It's great to be here.
Thank you. Eric, given your extensive experience on the predictive analytics side of the world, I'm curious with the latest focus on Gen AI. Traditionally, we've always thought of enterprise analytics as always just predictive analytics. So what's happening in the enterprise? Are more budgets going towards traditional predictive use cases, or are predictive use cases becoming generative, or are all the budgets going towards generative? What are you seeing in the enterprise?
Well, I haven't done any formal industry research, but I think it's clear from a million conversations at our conference and in running the startup, which is focused really more on the predictive side. I would say there's a trend that a lot of budgets are going away from predictive and towards generative, but that's not a sweeping statement. First of all, there's plenty of exceptions. Plenty of people are like, this generative stuff, it's overhyped, or we don't quite see the value proposition. It's, but predictive has a clear one for us. So it really depends on the organization or group or department or individual data scientists. And it really varies like crazy. But that kind of brings me to a message that I've been trying to relay in recent months or more, because generative AI kind of sucks the oxygen out of the room. Now, we really shouldn't necessarily have to compare the two as if it's a competition, right? It's really apples and oranges. Now, to be clear, what we're talking about are different categories of use cases of machine learning. And machine learning is always predictive. You call it enterprise machine learning projects. Predictive analytics, predictive AI was probably the new upcoming term for it. That doesn't allude necessarily to a particular type of machine learning. It's the way you're using machine learning. And those are the use cases where you stand to improve any of your existing large-scale operations. You predict who's going to click, buy, lie, or die, commit an act of fraud, turn out to be a bad credit risk, good location to drill oil, a satellite's going to run out of battery, a train wheel that is going to fail, right? And all of those things, when you predict them, pretty directly prescribe the action to be taken. Okay, well, let's investigate that train wheel. Let's investigate that transaction that might be fraudulent, right? And that's where you stand to improve your existing large-scale operations, right? Whereas generative is obviously generating new content items, even though at the core, machine learning is always predicting the next word or token, what have you. And obviously, there's a million other use cases for generative, but it's really quite different. And the two should compete no more than water parks and ski resorts. But they do compete. And that's largely because they both fall under this general umbrella of AI, which is somewhat arbitrary and not well defined. They're both uses at the core of machine learning, but that's neither here nor there when you're looking at the potential value. One thing's for sure is generative is the big shiny object, and it's much more fun and cool from a subjective standpoint in many people's experience or opinion, right? I mean, generative is much easier to use than predictive AI by definition because it works with English or other human languages. You can interact with it. Anybody can use it. Anybody and their uncle can just go start asking questions of a chatbot or what have you. On the other hand, perhaps generative might be easier to use, but harder to use well in the sense of driving enterprise value. and provably so. Um, so, should there be a standoff between the two? Not necessarily. But in a sense, there does end up being, you can't really help but make comparisons between them.
Makes sense. And given that you were measuring business value and your company Gooder's focus, and earlier in our conversation, you were alluding to the 6 steps business playbook that you had put together. Could you help us
Yeah.
understand how does Gooder help determine business outcomes of AI?
So AI is generally hyped in the sense that there's mismanaged expectations. We expect the world of it and see it as a panacea, see artificial general intelligence as around the corner and all these kinds of things.
Mm-hmm.
But there's also lots and lots of qualified techies and data scientists and users of both kinds of use cases, both generative and predictive, who have their heads squarely screwed on correctly and recognize, hey, look, the antidote to hype and the ultimate purpose of these things is to focus on concrete value, credible value propositions and use cases that are going to improve operations in some way that's provable, measurable, concrete, and actually makes things run better and therefore translates into bottom line improvements by one business metric or another. So what I did in the AI playbook is I present a 6-step playbook or paradigm practice discipline that I call Biz ML, business practice for running machine learning projects. It's focused and tailored for predictive AI or predictive analytics projects in particular, but the general framework, a lot of it applies to generative as well. And it starts with focusing on the concrete value proposition. In the case of predictive, what's predicted and what's done about it, exactly how are you using it, what are you predicting, and what operations will be improved. You have to change operations to get that improvement. That's the deployment, and that's the part that's so often not successfully completed. So these projects actually more often than not, fall short in that respect, which is an issue. So that's why I wrote the book. And that first step is literally only the first of 6 steps. So a lot of people know, okay, well, yeah, we need to start on a concrete value proposition. Great. But then you need to kind of follow through pre-production steps, main technical steps, which include prep the data, train the model, and deploy it, integrate it into operations. When you break it down to sort of the major 6 steps, the really important thing, and this is the broader message of my book, is that you need to get a really close collaboration between business stakeholders, the customer of the data scientist, the person in charge of operations meant to be improved by a model. You need to tightly collaborate with data scientists, right? It's that tech business divide that so often remains divided. But by collaborating deeply, and this is the often missing part, that the business stakeholder has already ramped up on a certain semi-technical understanding, getting into concrete details of what's predicted, how well, and what's done about it. And that trio, and getting a good concrete sense, digging in a little bit, very accessible, interesting, pertinent, understandable, getting ramped up on that. That's actually the main purpose of my book, The AI Playbook, is to ramp up the business readers. Although I think it's just as valuable to the data scientists who are so focused on just the maximizing technical metrics without the business pre-production steps, right, which are part of the system that does keep failing to reach deployment in the majority of these new enterprise ML projects. So if you can get everybody ramped up and on the same page, they can speak the same language, and you can have this deep collaboration from end to end across the project. So I call that 6-step practice Biz ML. But the basic idea applies to generative as well, the general ideas, which is you got to focus on exactly what operation is going to be improved, with what exact technology, in what way, what's going to be your measure of performance that matters, right? What's the KPI? How are you going to measure it? What's your goal for it? And then actually follow through on measuring it.
Okay. And you make a very valid point of better coordination and kind of coexistence between the business and the analytics teams to increase the chance that a predictive model would go into production, right? But when you look at a typical org of a Fortune 500 company, there is the VP data science who probably that org probably goes up into a chief data officer or a CIO, and then there is the business side, let's say VP marketing, chief marketing officer, CEO. So where is this a change management problem? Is this a process problem? Where do you think the solution starts for these two teams to coexist and build things more collaboratively?
I wish that I had a a great answer that applies across organizations. But the
Hmm.
fact is, the way organizations are structured and
Hmm.
the defined scope of each of those types of roles varies so greatly from one to the other that
Hmm.
I've remained intentionally agnostic.
Hmm.
So my main point is that, look, somebody's got to lead the project
Hmm.
from an organizational standpoint, right?
Yep.
ML ops is meant to be the solution to get these things deployed. That's the
Hmm.
ops,
Hmm.
operationalizing the model. That's to
Hmm.
deploy it. And it is ultimately change management in the sense that only by operationalizing, only by actually changing existing operations as informed with the predictive probabilities output by a model, only
Hmm.
with change, you can't improve if you don't change, right? So
Hmm.
that actual change, that deployment needs to be in place. So it is a
Hmm.
change management project, which is
Hmm.
often not quite recognized. The overwhelming focus is on the technology, like we're more excited about the rocket science than the launch of the
Hmm.
rocket,
Hmm.
right? And it is really cool rocket science, right? Learning from data to predict.
Hmm.
And that's why myself and probably most data scientists got into it in the first place, um, which is that's sort of the coolest thing in science technology, in my humble opinion, right? But what would also be cool would be realizing value, not only generating value by making a model that predicts well, but capturing that value by getting it deployed.
Yeah.
So the it depends on the mindset of the individuals and the person who's actually running or managing the project. Any
Hmm.
one of these projects um, could have a background that's more on the technical side or more on the business side. Whichever the case is, that project management discipline,
Hmm.
that organizational procedure has got to be the dog that wags the ML ops tail. ML ops is just technical. Now,
Hmm.
of course, we need technical, but this is a
Hmm.
business project that uses certain technologies, including the machine learning training algorithms, any ML ops to help manage and actually integrate the models in the technical sense of deployment.
Hmm.
Um, but there needs to be an understood, most business professionals out there don't even know that these projects require a very particular specialized project management paradigm or discipline playbook, let alone know the name of anyone, which is why I worked really hard to coin this really cool buzzword, Biz ML,
Hmm.
BIZML,
Hmm.
right? To put a brand on it and say, hey, look, let's try to evangelize this not only across data scientists, but business users, business and the end customer, the stakeholder, so that they can collaborate, understand, get on the same page. What are the sort of major steps and what are the semi-technical details that they really have to dig into, get their hands dirty? Because if your hands don't get dirty, your feet will get cold. They'll
Hmm.
balk at deployment. They'll essentially kill the project when push comes to shove, and that's what happens routinely, more often than not. There's plenty of successes, but a lot more failures, unfortunately, to date. So
Hmm.
this is what it means to sort of professionalize the field. So exactly who runs it and how you're interacting, what the different rules are in the organization, that's sort of up to you. But if you're involved with a project and you're not leading it yourself, I would venture to say you should at least make sure somebody is leading it who's following a holistic paradigm that brings together, fosters that deep collaboration between the two sides,
Hmm.
end to end across the project.
You know, like you alluded to earlier, Eric, everybody is familiar with a low percentage of predictive projects making it to deployment for some of the reasons that you just mentioned. Um, how do you think that carries on to the generative world? Do you think the chance that those things go to production is a lot more, or not necessarily?
Um, I think that the chances of them going to production are higher in general
Hmm.
because deployment is just opening a chat bot, right? I
Hmm.
mean, if I want to use this thing to make a first draft of my
Hmm.
marketing material,
Hmm.
um, I just open it. Now, there's plenty of other projects where integration is a lot more complex, but still, I would venture to say perhaps not as challenging
Hmm.
to get consensus on deployment. So, for
Hmm.
example, if in a predictive use case, I've got this thing automatically at a very high speed processing credit card charges in real time,
Mm-hmm.
many of them, right?
Mm-hmm.
Um, and for each one, it needs to make a prediction, an assessment. It has to run the model to say, hey, what are the chances this is fraudulent? So it can make a decision automatically on the fly of whether
Mm-hmm.
to block or hold that transaction as potentially fraudulent. That means a change to an existing vital, high stakes, high speed operation,
Mm-hmm.
right? That it's hard to get a change like that made. That's a big deal. Now, of course, it's exactly those kinds of high stake operations where you also stand to gain the most, right?
Mm-hmm.
That's where the most potential upside is, right? But where you stand to gain the most, you also stand to risk, and there's complexity and organizational issues and inertia and longstanding, there's lots of reasons people resist change, right? Now, if you're just sort of using uh, a large language model or any other generative AI in a relatively ad hoc manner,
Mm-hmm.
there's very low barrier to get it going.
Mm-hmm.
Other projects though, where they've proven performance results would be to help customer service. So let's say you've got human customer service agents.
Mm-hmm.
They're interacting over a chat bot to the end customers. And what they did was they tried a large language model that would suggest copy, maybe a paragraph or sentence that you could copy, paste, edit as you want, you as
Mm-hmm.
the customer service agent, and then use that. And that really improved, I don't remember, somewhere between 15 and 20% number of tickets resolved per hour. And then for new, more neophyte customer service agents, it actually improved their rate by a third.
Mm-hmm.
Right. So it's interesting, right? Because made that help them even more. But actually getting that interview, if you've got a big customer service team and all of a sudden you've got to integrate on the screen the way it's going to bring the decision of which large language model and what prompt engineering and how it's going to pull from the existing chat, generate a potential response. How is the UI going to work so they don't have to copy paste or just click OK or do edit or however they did that.
Mm-hmm.
That's a deployment thing. So I would kind of say intuitively that that's got a lower, even that has a lower barrier than a lot of these high volume predictive use cases. But again, let's take a step back, right? It's sort of like, why does the world have to compare?
Mm-hmm.
Well, I do think there is a reason that we have to compare, which is because largely both of these very different kinds of use cases, predictive and generative, fall under the same umbrella and often eat out of the same budget. And right now,
Right.
because everybody's so excited, there's this sort of intrinsic pressure to do generative rather
Mm-hmm.
than taking a deep breath, step back, and take a sober look at, hey, what's the lowest hanging fruit? Where do you
Mm-hmm.
stand to gain the most? What's the
Mm-hmm.
biggest potential of value proposition?
Yeah, makes sense. Makes a lot of sense. That's wise advice. And if a CIO or a CEO was or a board was taking a step back and taking a breath and assessing from first principles and trying to say, hey, predictive is still super valuable for enterprises. From your experience, what are some low-hanging use cases they should pay attention to begin with?
Yeah, I mean, as I mentioned, fraud detection, targeting, marketing, credit scoring. But the thing is, it depends on your industry and your particular company.
Hmm.
Where the lowest hanging fruit would be, well, what's the largest scale operation, right? Large scale operations are generally made up of many, many individual decisions that come
Hmm.
down to treatment. Which
Yeah.
healthcare patients should be re-examined or retested before allowing them out of the hospital? Which location should I drill for oil? Which train wheel might break down, right? Reliability modeling, IoT, predictive maintenance, marketing,
Hmm.
credit scoring, and then, of course, lots of insurance applications. And it just depends on what your operations are, your
Hmm.
company or your department or whatever you own.
Yeah.
What's the largest scale operation? So, and along the same lines, it doesn't necessarily matter how large the company is, right?
Hmm.
Even a small business that has a large enough number of operations. Let's say you're sending once a year an annual holiday catalog to
Hmm.
sell some gifts
Hmm.
or candy or something like that. If you have a large enough prospect list and you have the experience of the data recording the experience from a year ago, if these are the people contacted and these are the ones who actually responded by buying, that's experience from which to learn. If it's a large enough, if the operation is large enough, then the data tends to be large enough because you're sort of as a side effect of doing business, right? You're logging those transactions, and that's the experience from which to learn. So, as far as like rules of thumb, that's the main one. If you're focused on marketing in particular, there's two main use cases. One is for targeting marketing for acquiring new customers or new purchases. The other is retention. So if it's ongoing business, if they're subscribers or they're repeat customers, you want to, this one actually may be a little bit less well established, but it's probably the hotter application where there's oftentimes the lower hanging fruit, because retaining an existing customer tends to be a lot less expensive than acquiring a new one off the street.
Yep.
However, it can be expensive to convince a customer who was on their way out or destined to depart, convincing them to stay, often a hefty discount, something you can't offer to your entire customer base. So by definition, prediction is the only recourse for doing that efficiently.
Okay. And, the work you do in your company, Gooder, helping companies assess business outcomes to AI, is that a quantitative metric that you're showing them, or what is it that you show them?
Yeah, what we're doing, Gooder, is the sort of one main missing technical component from today's ecosystem machine learning software, and fits as part of this Biz ML practice I'm espousing, right? One of the 6 steps, as I framed it in the AI playbook, is establishing the metrics, right? Which are then part of the whole project. When you're training the model, what are the metrics you're trying to improve, and how do you communicate that to stakeholders? What happens today is data scientists universally almost always evaluate models only with regard to technical metrics, like precision recall, area under the curve. Even accuracy is a technical metric, versus the business metrics, very straightforward KPIs like profit and savings, that kind of thing. The thing that organization cares about, that the lingua franca of business, the thing that the stakeholder cares about. And for those of you who've never been involved with a predictive project, you may be surprised to hear it, but because it sounds so obvious, of course, we want to estimate or forecast the potential business value in concrete business terms of this model before deploying it, before changing large-scale operations. But no, the deployment is often conducted as a shot in the dark, and more often not conducted at all, because it would be a shot in the dark, because there's no regular practice, there's no customary or well-established framework for estimating the potential business value before deployment, before redeployment, before champion challenger refreshing with a newer model over new data, et cetera. Our thesis is that this is central to the dilemma so many organizations are facing, where the project doesn't get deployed. It's that divide between tech and biz. It's the inability to say, hey, no, look, we can actually show a real clear way of estimating. So and one of the reasons is, you said I've been in the field of machine learning almost 30 years, but the fact is I've actually been in the field of machine learning for more than 30 years.
Oh, wow.
Not to pick a nit, especially if you include grad school, which is really when I got started. I went to grad school at Columbia University before I was a professor there. It's high time that we actually start regularly involving business metrics into the practice, both in terms of the development of the model as part of the training and testing that we're doing during the development, and as far as communicating with business stakeholders and planning whether and how a model is ready to be deployed. But to do so, to make this much needed fundamental move from technical metrics to also assessing in terms of business metrics, that is to say, stress testing the rocket in its intended usage, that to make that much needed move opens a can of worms. And it's a little bit hairy. It's, just like any forecasting, there's certain can of worms, there's certain assumptions. So there's usually business inputs, factors, false positive, false negative cost, or the way you derive those and things like that, that are part of what ends up being pretty straightforward arithmetic to roll up the performance of a model into these aggregate forecasts of their actual KPI impact, that are subject to change and uncertainty. And because of that, you need a specialized user interface where you can parameterize that, put them as sliders or some kind of controls on the screen, and actually move them and see how it changes the shape of the profit curve or the savings curve. So that's our thesis, is that what the machine learning field needs is a new category of software. This is not the model training parts, not the rocket science parts, this testing the rocket its intended usage. So doing so is how you address that can of worms.
Yeah.
And doing so is solving two different business problems. One is the development of the model, and the other is the communication and getting the buy-in from the business stakeholder. So in the first of those, development of the model training, model development is only semi-automatic, right? This core rocket science is automatic. It's an algorithm, that is to say it's a PhD tool, push here, dummy, you set it up, I'll set up the training data and the parameters, and you push a button and it makes the model. That's model training. But model development is a slightly broader concept, is semi-automatic, which is train, test, train, test, train, test. It's iterative. It's an experimental thing. It's always got an experimental nature to it. The testing part is broken, because if we're only evaluating in terms of technical metrics, if you're not assessing business value, you're not pursuing business value. How do you know that you're navigating that model development process in the right direction? The technical metrics tell you little to nothing about the potential business value. They tell you it predicts better than guessing, is generally the easiest way to explain what most of them do, which is very good to know. And it means that the model is potentially valuable, but doesn't tell you anything about how valuable it could be. The second business problem is crossing that biz tech divide and going to a stakeholder and saying, hey, look, I'm not going to just tell you that the area under the receiver operating characteristic curve is 0.83 and hope that you'll think that sounds good enough to deploy it. I'm going to show you an estimation of the business value and allow you to play with the parameters. Where's the decision threshold? Where are these other things that are subject to change and uncertainty going to sit? What's our best Fermi estimation? Where's there too much uncertainty so that we have to go out and get more data to narrow that down, or what have you? And then you're providing them, they're putting them in the driver's seat, which is where they should be. This is a business project for business value, and the business stakeholder needs to retain this kind of control. They need a very particular kind of business console or control panel to view the potential value and benefits of predictive model deployment. So having said all this and pitched our product, GooderAI, I should also couch that by saying we're a very early stage startup, and we're just going to trial deployments with early access customers. So literally only 2 so far on actual real production models. Plenty of others have just tried it out more casually. And then a whole bunch more, more than a dozen lining up for these trials. So for those who are listening, if you're working on a predictive model, early stage or late stage, or refreshing it, we'd be glad to talk to you about a potential trial.
Perfect. And I completely agree, which is this fundamental disconnect between the way machine learning works, which is, like you said, iterative, probabilistic, stochastic, whereas business teams a little more used to seeing things in black and white. I think kind of that kind of provides kind of a chasm between these two teams and taking these things to deployment successfully. That makes a lot of sense.
Yeah, totally. Yeah. So, I mean, and that's, I mean, in general, whose fault is this? Is it the techie's fault or the business person's fault? It's both. There's this no man's land, right? One or both sides has to reach across the aisle, right? The business stakeholder can't just delegate this project like a technical project. Hey, go update our database or something like that. This is different. It's an operations change project. And so we need to reframe it. Calling it a machine learning project puts the focus in the wrong place. So right now, there's a trust thing. It's kind of like, well, they're the experts. They know what the area under the curve is. They sound like they sound convinced about it. We see their credentials. We're just going to delegate it. But you got to get involved in those semi-technical details. I mean, you're the one, if you're the business side, in charge of this large-scale operation that's going to potentially be changed and thereby improved by way of predictive probabilities. That's what it comes down to, which is
Hmm.
just because it works with probabilities doesn't mean it deals with hairy math. I mean, a probability is just a number between 0 and 100 of what are the chances of this outcome or behavior, right? We don't have a magic crystal ball. We have the next best thing, which is some
Yeah.
number in that range. And
Hmm.
being able to put that number, and if it's
Hmm.
at 50-50, it's a sort of a lack of insight. It's like I don't know. If it's close
Hmm.
to 0 or 100, it's more certainty. And those are the cases you're more likely to act on. But making those determinations, where you draw those thresholds and all that, it's not rocket science. It's
Yeah.
just concrete mechanics of how am I using these probabilities to run projects. And that's what it takes to actually get involved in some level of detail, understand concretely how it's going to improve your operations.
Makes sense. So switching gears a little bit, Eric, you were mentioning that you've done over 150 keynote talks over the last few years, and you've written a couple of solid bestsellers. So when you're out there doing these keynote talks and meeting the community, what are people mostly asking you? What do they want to hear you talk in these keynotes?
That's a great question. I say a lot of it this year is what we've been talking about today is sort of like, well,
Hmm.
let's get clarity on predictive versus generative and how do you
Hmm.
balance the two and how do you snuff out the hype, focus on concrete value propositions. More historically, I mean, up until a couple of years ago,
Hmm.
enterprise machine learning projects were basically just of the predictive variety, right? Generative
Yeah.
is a whole new thing now that it works as astoundingly well, right? It's
Hmm.
uncanny, it's extremely impressive and has lots of potential value.
Yeah. Yeah.
Um, and I know that's also true about your company, ProjectPro, right? So most of us who've been in the field, have a vast majority of history is focused on predictive, and that's what my first book focuses on, obviously, right? But you can tell from the title, Predictive Analytics, the power to predict who will click, buy, lie, or die, right? It's got that catchiness to it. So it was the first sort of business reader accessible to any newcomer or non-technical reader, as well as data scientists. I think in order to cross that chasm and make it concrete, specific, and accessible, which is what I've ended up doing so much with keynotes. In fact, I'm much more often a keynote speaker for other conferences than my own. My
Hmm.
conference series, Machine Learning Week, is for
Yeah.
people who are already in the field. They don't need the
Hmm.
basics, right?
Hmm.
Although about a third of the audience is more business
Hmm.
side and
Hmm.
newcomers, which
Hmm.
different. So it's not just there's a business track. It's not just a technical conference like most machine learning conferences.
Yeah.
Whereas when I speak at other conferences, I've spoken at, a couple dozen different sectors. I'm looking at the list here: market research, government, human resources, travel, real estate, construction law, et cetera, right?
Hmm.
Because it's generally applicable. It's a very horizontal technology. The Harvard
Yeah.
Business Review called it the most important general purpose technology of the century, right? And that's panned out. So both that subtitle, the click, buy, lie, or die, and sort of the way I position myself, I'm like, look, this applies to everything. Whatever sector you're in, would you like to hear how it potentially applies in yours? So that's
Hmm.
what I end up doing is sort of give the overview and gist of predictive. But it also depends on the particular conference. Sometimes it's a more technical conference, people who are already analytically experienced, or if it's an analytics vendor, maybe about 20 or 30% have been for analytics vendor events, customer
Hmm.
facing events of my speaking engagements. So it does very widely in the government sector. It ends up being a bit more on the ethics side.
Hmm.
So,
Hmm.
I mean, machine learning deployments and Gen AI deployments are just so address such a wide berth of operations, um, are so generally applicable, and yet bring up so many questions. Right? There's a lot of topics.
Makes sense. Makes sense. And just just as a final question, as you kind of look towards the horizon, and with Gen AI, it's tough to see where the horizon is. It's next week, next month, next quarter. What do you see coming up? What are you most excited about? AI broadly, not specifically Gen AI.
I mean, that's a great idea. And the thing is, as far as what's exciting to me, I've always kind of had a split personality, right? So I'm a nerd I love the technology, and as I
Hmm.
mentioned earlier, that's sort of why I got the learning from data to predict so awesome. I've also always been interested in natural language processing. I was in the natural language processing research group at Columbia for 6 years.
Hmm.
It's all edge cases. I never thought I'd see what we see now with the ability of large language models in my
Hmm.
lifetime.
Hmm.
So that's incredibly cool. And then when you start making it multimodal and doing it's doing video, I mean, we keep seeing these astounding new levels of capabilities, which are so cool. So I do love to geek out on that.
Hmm.
And if I didn't have to work for a living, I'd probably just sit around playing with large language models because that's
Yeah.
sort of my geeky personality. But I've also, over the last 20 years as an independent consultant and then starting this company a year ago, have been focused on the business applications. So I'm more about, hey, look, this stuff's cool, it's fun, whatever. Let's focus, let's 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 have this party pay for itself, right?
Mm.
Let's start focusing on concrete use cases that actually get to deployment. Let's measure how often this stuff is sort of vaporware or hype or narrative or theatrical
Mhm.
versus actually concretely deployed so it makes a difference. And there are plenty of amazing cases, and that's been the bread and butter of my writing and of the conference speakers that we have at Machine Learning Week. Um, uh, so there's plenty of success cases. It's just that right now there's way too many. There's so many failures. Our industry research shows that. We've published it. It's easy to find. IBM, instead of uh, surveying data scientists like we do, surveyed, and by we, I mean myself in partnership with a couple different organizations in these different industry research. But IBM surveyed the executives, got very much the same story, and the result was that these enterprise ML projects have basically no returns on average.
Mm.
To be more precise, the average returns were lower than the cost of capital, which means that it would be more cost effective to just invest in an index fund instead of investing in a new predictive project, um, because they're not getting deployed, right? So my focus is like, let's actually pursue concrete value. And on that page, I do see some good, if slow, evolution. I'm trying to contribute to that by saying, let's put a buzzword, Biz ML, let's call it Biz
Mm.
ML, and get everyone on the same page that there needs to be an organizational paradigm to pursue and ensure value rather than just this party around how cool the technology is and being in love with the rocket science. And it's okay to be in love with the rocket science, but not at the detriment of business value.
That makes a lot of sense. So thank you, Eric. This has been extremely helpful and inspirational. Really appreciate
Thank
you
you.
taking time to do this.
Yeah, my pleasure. Thanks for having me on the show, Benny.